In the beginning there was man. This man was very clever and created fire. He then burnt down his cave, which led to the question, how could man protect his cave from fire? And the answer was water. Lots of water. Man could carry it in a bucket, or many buckets, and then a smart guy built a pump. Now man could throw water a great distance, and these pumps evolved from hand through the golden age of steam, then the motor vehicle, up until now. As technology progressed, man had built some magnificent vehicles, but was still putting out fires the same old way. Then another smart guy did some calculations and determined that the extinguishing power of water could be enhanced up to 7 times by introducing thousands of bubbles. So the commissioner said, "We must embrace this new technology," and a legend is born. Introducing the Queensland Fire and Rescue Service Type 4 Medium Urban Compressed Air Foam Pumper. They're seating for 5 firefighters and comes equipped with a waterless compressed air foam system, a waterless 2-stage pump, Acron remote control monitor and plenty of storage for a full complement of gear. The Scania CAFS pumper is the next generation of firefighting vehicles. Compressed air foam, or CAFS, is not a new idea. It's just an improvement on the way we deliver foam. Any CAFS system consists of 3 elements: water, foam concentrate and air. For the Queensland Fire and Rescue CAFS Scania, water is made available from the 1500 litre onboard water supply, the reticulated mains or a static supply. The foam solution is the standard A-class Solberg concentrate used between 0.1 and 1%. And the compressed air is introduced from the onboard 140 cubic foot a minute Rand industrial compressor. The water and foam concentrate are mixed by the Advantis foam proportioner to form a foam solution. The foam solution is then made available to the near side hose reel, case 3 delivery and the roof mounted monitor. Compressed air is introduced at the point of entry to make the bubbles and further mixed in the hose line prior to delivery at the branch in a process known as scrubbing. A-class foam concentrate is similar in chemical properties to ordinary dishwashing liquid. What makes it so effective in extinguishing A-class fires is its ability to reduce the surface tension of water and allow it to penetrate deep into ordinary combustibles, or A-class materials.
Can you see there that the water is beaded up? It doesn't flow, it doesn't accept into the A-class material, the ordinary combustible. And now I'll demonstrate what can be achieved when A-class solution can be applied to the same material. And what you'll see is that it will remove the surface tension of the water and it will be absorbed and stop water runoff included into the A-class material. You can see there straight away, it's straight away absorbed more readily. Where you can see the original application of water, it still retains its surface tension.
When A-class solution is mixed, the current method of application is by aspirating, or introducing air into the solution at the nozzle using a foam branch. As you can see, in comparison with CAFS, the bubble structure is not as uniform and does not have the capability to adhere to vertical surfaces as effectively. This also affects the extinguishing properties, as CAFS produces an excellent foam blanket that excludes oxygen and delivers A-class solution over a longer period of time as the liquid drains from the bubbles. Being an A-class foam, the surfactant properties of the solution allow it to penetrate deep into A-class materials. This increases the rate of heat transfer to cool down the material. The rate that air is introduced into the solution gives the incident controller and branch operator the choice of 3 foam consistencies with different characteristics. These are wet CAFS, medium CAFS, and dry CAFS. Wet CAFS can be thrown considerable distances, is hard-hitting and has good penetrating power with a very fast bubble drain time. It is used extensively in offensive operations, particularly in the I zone. Medium CAFS is a good compromise for throw, penetration and exposure protection, and the construction of control lines, particularly in I-zone operations. Dry CAFS is an excellent thermal barrier for exposure protection. It adheres very well to vertical surfaces, but it can be affected by the wind. Dry CAFS has a shaving cream-like consistency, but cannot be thrown or projected as far as the wet CAFS. As you can see, these three foam consistencies give the incident controller flexibility to use CAFS as required for the specific need and application. CAFS is a very versatile tool on the fireground, but be aware it does have limitations. Whilst designed primarily as an urban pumper, the Queensland Fire and Rescue Service has adopted the policy that CAFS is not to be used for internal offensive operations. For all other applications, CAFS is proving to be an excellent tool in the incident controller's toolbox. You can see the effectiveness of CAFS when used at motor vehicle fires. This test conducted at the live fire facility at White Island shows the rapid knockdown of a vehicle fire with a 5-minute pre-burn. Note the colour change in the smoke as the CAFS bubbles strip the carbon from the smoke. This well-involved motor vehicle fire was extinguished in under 2 minutes with a concentrate percentage of 0.3%, just 479 litres of water and using 1.8 litres of foam concentrate. CAFS in the urban role can also be used for exposure protection and is very effective to knock down fires in timber structures that dominate building in Queensland. As you can see in this video, less than 10 seconds of indirect application of CAFS streamed through the window knocks down a significant body of fire. Another area in the urban environment where CAFS is being trialled is as an interim measure to control running hydrocarbon or fuel fires. A-class foams have poor resistance to burnback and limited vapour suppression capabilities, but as you can see, it's quite effective at minimising fire spread, and research in this area is continuing. Training has been conducted in Brisbane for the use of CAFS in the I-zone. Trainers from the ACT Fire Service worked with the QFRS on tactical application of CAFS in the I-zone operations. While CAFS has excellent knockdown power, it's been trialled extensively to assist in the making of control lines and is an excellent tool to avoid rekindles and blacking out bushfires. Perhaps the most important application for CAFS is the ability to protect structures and vehicles in the path of an oncoming wildfire. Using a wet CAFS and following with a dry CAFS blanket will produce an excellent thermal barrier which will greatly assist property protection. There are two Scania Type 4 urban pumpers that have been outfitted with compressed air foam systems, one based at Capalaba in Brisbane South and Windsor in Brisbane North. These pumpers have all of the standard features of an urban Type 4 with the addition of the CAFS system, and can only be used as a CAFS pump in accordance with Brisbane Standing Order SO5BM 3.18 CAFS crewing. Working with Project Manager Acting Inspector Shan Raffel, Brisbane Regional Development Officers Tony Eggins and Wayne Brown have trained 64 CAFS officers and operators across all 4 shifts. The trial period runs for 18 months and relies heavily on officers outside these stations to recognise the benefit of a CAFS pumper response and special call a CAFS pumper to any major incident. This is the only way we can effectively evaluate this new technology for future applications.